Today we will see this question on functions. We can see some exponential and modulus functions are involved. Basically, we need to find the values of a and b in this question such that this equation has four distinct solutions. So let's see. First, we will draw the graph of e to the power x. This looks something like this. Next, we draw the graph of e to the power mod x. In this, we take the reflection of the positive part of the graph in the first quadrant along the y-axis. Along the y-axis, we reflect this, and this becomes something like this. Next, we have e to the power mod of x minus b, in which we have shifted the entire graph by b units to the right side of the x-axis, right? So this point where x is 0, that point on the y-axis becomes e to the power b, and where y is 0, x becomes b. Next, we draw e to the power mod of x minus b minus a. So basically, we are shifting the entire graph down by a units. So that's why where the point that was e to the power b becomes e to the power b minus a. Another point to note is that the x coordinate that was b, that stays the same as it is because we're just shifting it down. And this entire length is a because we're shifting it down by a units. This much is 1. So this becomes a minus 1. But since it is in the negative y-axis, we have written it down as minus of a minus 1. Next, what we see in the entire function that we wrote the previous graph of, we have put a mod of the entire function, right? In this, what we have done is the part in the negative y region, we have just reversed it or flipped it along the x-axis and removed the y part. So that point becomes b comma a minus 1 because minus of a minus 1, that was in the negative region, right? Now we are done with plotting the graph. We will now have to see how many solutions it gives with y is equal to 2. So the dotted line that we see is the y is equals to 2 line. You can see if and only if the y is equals to 2 line goes through this region, that means y is equals to 0 to y is equals to b, only this much region. Okay, don't confuse it with this point. Y is equals to b and y is equals to 0, this much area. If y is equals to 2 line passes through that, then only we'll get four solutions because it cuts the graph in four places: 1 2 3 and 4, right? So the y coordinate, that is a minus 1, needs to be greater than 2. So that's what we have done, a minus 1 greater than 2. So from that we get a greater than 3. See, you can't even use greater than equal to, because if we put greater than equal to, you will get three solutions because alignment passed through a minus 1. And b can take any value, so b belongs to real. So this is the solution, a greater than 3 and b belongs to real.